Alright. Hello, people. How's everyone doing? Alright, so last time we did Vulcan stuff, it was over a month ago. I was supposed to do this every single week. And then I got busy with my own game studio. I got busy with work. I got busy with clients. I got busy with teaching. I got busy with life in general. And yeah, I haven't had really much time to do this. I mean, that's kind of a lie, because I've been streaming Halo, been playing Halo lately, and so I could have taken that time to do Vulcan stuff, but no. Anyways, here we are. So today, I'm gonna continue where we left off, and set that validation layer. I remember looking at it, and it was a pain in the freaking ass. So, Vulcan tutorial. Vulcan tutorial. Alright, so drawing triangles, set up validation layers. Motherfucker, are you kidding me? Alright, so that's what we have to do. That is the boring thing. Did I do the physical device and Q families? I don't remember. Let's see. What did I do? Ooh, too zoomed in. I initialized Vulcan. We went through the initialization process. We picked a physical device. That's good. And that was about it. We didn't do the Q families. Did we? No. Did we not? Did we? Did we not? Actually, stop at physical device. I didn't continue. What? Why didn't I do Q family? I mean, it's right there. Alright, well, we need to do the Q family. And physical device, CPU, geometry. Yeah, that's all we did. Kind of a shame. We barely did anything. Jesus Christ. Alright, so if I run the engine, all I get is device count is 1. We selected strict GPU, supports geometry shader. Physical device selected is 0. Physical device selected is 0. Why is physical device selected 0? Oh, that's the index number. Physical device index, or physical device index is, say that, because otherwise I would get the idea of there are 0 physical devices that were selected, which is wrong because that's not the case. There was a physical device selected and set the index 0. Alright, cool. So, okay, we'll do the validation layers later then. We'll just keep going in the Q families. Let's see. Alright, so we got the physical device. And so that's the actual device that you need, like an actual GPU, right? So we were queuing for all the GPUs in the system, and we're trying to find the most suitable GPU to run Vulcan with kind of the specification we want. And the specification we set here is just a discrete GPU. That's it. That's all we did, and it supports geometry shader. So if a GPU is discrete and it supports geometry shader, we're good to go. We picked that baby out. Alright, let me drink some coffee. Oh, I got my coffee, by the way. I'm all set for like 4-hour stream. I have no idea if I'm set for 4-hour stream. It's 11 p.m. I have a class at 10 p.m. at 10 a.m. So I don't know, maybe 3 a.m. I'll sleep at 3 a.m. I don't know. 3 a.m. to 9 a.m. is what, 6 hours? Ah, that's enough for sleep. 6 hours sleep is enough, I think. Probably not. Alright. Cool. So let's our physical device. Okay, cool. Q families. It's been briefly touched upon before that almost every operation in Vulcan, anything from drawing to uploading textures, require commands to be submitted to a queue. All right, so we have a queue, right? And we submit commands like draw stuff on it. Got it. There are different types of queues that originate from different queue families, and each family of queues allow only a subset of commands. For example, there could be a queue family that only allows processing of compute commands, or one that only allows memory transfer related commands. We need to check which queue families are supported by the device and which ones of these support and which one of these supports the command that we want to use. For that purpose, we will add a new function, find queue families, that looks for all the queue family we need. The queue families we need. Right now, we are only going to look for queue that supports graphic commands. The function could look like this. All right, baby, let's do this. All right, makes sense. We're in Vulcan, not Vulcan. We're in OpenGL. You basically. Oh, hold on. 1 second. Ooh, I found a screw on the ground. All right, so I took my today my friend gave me her laptop, and it was throttling. It was reaching like 99 Celsius on the CPU without doing anything. So I had to change the thermal paste and stuff, and a screw fell, and I forgot on the ground, and I forgot that it fell on the ground, and I didn't pick it up, and I just kind of saw it. So there you go. I need to remember to put that back together. Otherwise, she's not gonna be happy. Anyways, all right. So we have a physical device. What do we need? Come on, let's go. Let's do this. Okay, so our physical device. We need the structure. Okay. Okay. However, in one of the next chapters, we're going to look for another queue, so it's better to prepare for that handle. Okay, cool. So, find queue families. Oh, okay. So here he only made the function that returns an integer, an unsigned integer, and it returns find the graphics. And so he's just so he's doing kind of the same thing, except now there are multiple queue families he wants to find, right? So he's preparing for that from the start. All right, sure, we can do that. But what if a queue family is not available? Ooh, interesting. We could throw an exception in the find queue family, but this function is not really the right place to make decisions about device suitability. Yeah, I agree. So what you should do, just find all the queues, or the queue families in this function, and the function is going to return a list of all the results, and we can make a decision on whether we want a specific queue family or not. But this function, okay, for example, we may prefer devices with a dedicated transfer queue family, but not required. Therefore, we need some way of indicating whether a particular queue family was found. It's not really possible to use magic values to indicate the non-existence of a queue family, since any value of unsigned unit could, in theory, be a valid queue family index, including 0. Luckily, C++ introduced a data structure to distinguish between the case of a value existing or not. What in the fuck? Why are you adding so much complexity to this? STD optional graphic family. Bool alpha? STD bool alpha? Graphics family dot has value. False. Graphic equal 0. STD option is a wrapper that contains no value until you assign something to it. At any point, you can query it. You can query if it contains a value or not by calling has value member function. That means that we can change the logic to std family. What? Why the fuck are you adding so much complexity? Just why not do -1, and instead of doing an unsigned integer, make it a normal integer. So -1 means this hasn't been assigned. 0 is index 0, 1 is index 1, 2 is index 2. Why in the flying shit are you adding complexity using this std optional? God damn it, man. C++ people, I swear God, they thrive on complexity. They're like, how can we make adding two numbers the most complicated fucking shit in the world? I know, let's make a hash map that goes and finds a binary tree inside a linked list that can go and call this fancy structure inside a class with a for loop that goes into a database that connects to the CIA to connect all the computers in the world to I don't know what the fuck I'm talking about, by the way. I'm just making shit up. But I'm saying that my point is this shit is complicated. Just fucking make it just simple, man. Simple is good. Simple is nice. Why overcomplicate shit? Alright, fine. We're not using this std optional bullshit, by the way. So we're using just and we're not using a fucking unsigned integer, just using a normal integer. Fuck is wrong with you, buddy? Alright, but thank you for this tutorial, by the way. I really appreciate you for this tutorial. Without you, I would have not known what the fuck I'm doing in my life. I mean, I still don't know what the fuck I'm doing in my life, but I digress. Alright, Q families indices. Graphics family. Alright, sure. Fantastic. We can now begin to actually implement find Q families. Okay, let's implement that, baby. The process of retrieving the list of Q families is exactly what you expect and uses. VK get physical device Q family properties. In this function, can this structure get any longer? Kronos, please. Can you make this any longer? I bet you there's even a longer structure than this. I clicked on the fucking thing by mistake. I'm sorry. Where was I? Alright, here we go. Alright, cool. Cool. So the process of retrieving. Alright. So we have our Q family. So we're calling this, we're giving the device. This is gonna give us, yeah. Oh. That's why. Does this only take an unsigned integer? Oh no, I might have, like, spoke too early. It does only take an unsigned int. Can I just press an int? I'm sure I can pass just a regular int, can I? Can't I? I'm sure it'll be fine. Last words ever spoken. I'm sure it's fine. And then everything fucking explodes. Anyways. So std vector vkq family properties. Okay, so then so it fills with the data. This is Q families, which is, where the fuck is that? Q families. Where's it, buddy? What is this? Oh, that's right, I'm here. I'm so fucking blind. It's a vector with that. Okay, so it fills the data. First we queue for how like the amount of families, then we follow with data. Okay, good enough. Okay, that makes sense. This makes sense. Yeah, it's easy stuff. All right, we got this. Still, there's a million tutorial left to get a triangle, but we got this. Easy stuff. The Q family property structure contains some detail about the Q family, including the type of operations that are supported and the number of queues that can be created based on that family. We need to find at least one Q family that supports VKQ graphic bit. All right, baby. That's fantastic. Now that we have this fancy Q family, very fancy by the way, the fanciest shit I've ever seen in my life, we can use it to as a check in the is device suitable function to ensure that the device can be processed. The command we want to use, okay? Wait, what? Now that we have this fancy Q family, we can use a check is device suitable. Okay, cool. Yes, I understand. So this device suitable, do that. Okay, to make this a little bit more convenient, we'll also add a generic check to the structure itself. It's complete. All right, so okay. Jesus Christ, man! Jesus Christ, man! You're overcomplicated this shit, but I understand why you're doing all that. Okay. All right. Give me guys a second. Un momento, señorita, please. I don't speak Spanish, by the way. I am just making shit up. All right, here we go. All right, baby. Let's do this. We got this. We're the champions. We know what we're doing. We know exactly what we're doing. We are doing nothing. I don't know what I'm doing, but it's fine. We got this. All right. So what do I need? I need the physical device. I got a physical device. What else? What else? Come on. Let's go. What's next? Hit me with it. Oh, by the way, I upgraded to Windows 11. Oh, fancy, right? It's the slowest shit I've ever used, but it's nice. It looks very pretty, but it's unfucking usable. Kill me. All right, so where was I? Why do you keep scrolling up? Stop it. Fucking brick. All right, so Q family is finally Q family. All right, so we need this structure with this thing because he wants to fill the structure. Okay, you know what? I'm gonna go easy, simple and easy, and then I'm gonna just do this. All right. I'm just gonna try to write the code, not copy it. It's nicer. Okay, so do I ever use in the engine? Just want to be consistent. Do I ever use like an unsigned entity? I do. Device count. Oh, so I'm doing it also here. So he like it makes sense what he's doing, right? Okay. All right. Can I just do an int32? You'll be mad, right? So can I just cast this to a uint32? Wait, how what was it? You just like this, right? uint32 underscore t. Forgot the t. You not on int. What the fuck am I doing? Can't cast it. I'm a little bit rusty with C++, so how do I just tell it to shut the fuck up and just let it go? How do I tell it to just shut the fuck up and let it go? Okay. Okay, I have another idea. Okay, just because I don't want to use this optional bullshit, right? Because I just don't. All right, I just don't want to use it. So instead, what I could do, what am I doing? What is this? Instead of what I could do is I can set the initial value to the. Of course, this device count will never be less than 0. right? So what I can do is I can set the initial values to the maximum UN32 that can support. So max int uint 32 underscore t underscore max. Can I do this? Fuck yes. All right, and so if I put a breakpoint, this is the max number that this value supports, right? So this way, right? This is the maximum number. So now when this changes, I need just to make sure that it doesn't equal to the max, right? Because when it goes through this function, it's going to be 0, 1, 2, 3. It will never reach unsigned int. Like, that's just not possible. You're not going to have 4 billion graphics cards attached to your hardware. That's not going to happen, right? So now you can see now it's 1, right? And so, oh, this is device count. So technically, yes, it can't be. I mean, it can be 0, right? Oh, we can't do it here. This has to be 0. Okay. This is device count. We can have. Okay, so I'm gonna revert this change, right? But we can do it in. Right? This is the count. The count is fine. We can get 0 for count. But what we shouldn't have is the index. We shouldn't have an index of. Yeah, so here I can do -1. That's completely fine because, well, if it's not -1, it's good. But in here, that's not possible because this thing is gonna fill up. Okay. We got it. I got this. Okay, so I'm gonna do uint 32 underscore t graphics family equal to uint 32 underscore t max, right? Can I do uint, please? There you go. Okay. uint 32. Okay, cool. So we got that right there. Okay. And then Q family index. Okay. So Q family indices. Oh, that's the structure he made. Okay, never mind. I was like, what? I mean, it's supposed to start with VK. Alright, so don't care about that, don't care about that, don't care about that, don't care about that. Don't care about that, don't care about that, don't care about that. Here we go. Alright, so in here, let's VK get physical device Q family, Jesus Christ, properties. Okay, we need to give him the device. So, is it called physical device? Yes, it is. Next, the Q family bullshit. So, graphics family, right? And no PTR. All right. So what that's gonna do, this function is gonna run. It's gonna give us how many Q families we have, or the index number of the Q families we have. And so as long as it's not this value, it should be fine. Because if it's 0, that means it found something. I wonder what if it couldn't find? What value will it return? Is this described here? Must be a valid portion. Okay, that's fine. Here, if the value referenced by the Q family property count is not 0, a Q family property is not null. It's not. So wait. Get physical device properties Q family parameter. If a value referenced by PQ family property count is not 0, and a PQ family property is not null, must be a valid pointer to A. This is the count. This just returns the count. What is PQ family's properties count? This just returns the count. So 0 means there's nothing. So what's his issue? What's his issue? I mean, it's gonna return either 0, which means it's nothing. I don't get it. I don't get why he's using optional. I mean, it is because this is gonna return either it found something or didn't find something. So if the initial value is 0 and it didn't find something and set it to 0, then that's fine. That means it didn't find anything. What the fuck are you doing, buddy? He's doing it later on for the index. He's using the same integer for the index. Well, that's his fucking fault. He's using the value this as a count and as an index. Well, I'm sorry, buddy, but you shouldn't be doing that to begin with. Like, alright, whatever, buddy. Alright, std vector bk bkq family properties. Alright, and then we need a q family with the q family count. It does do a q count. I think I'm just fucking stupid. Honestly, I think I'm just dumb. He's not using the same variable. I think I'm just fucking dumb. That's really all it boils down to it, really. I'm lacking sleep. That's probably why. Alright, VK. Get. Ignore everything I've said this far. I'm just an idiot. That's literally it. Device Q family properties. I'll explain why I was an idiot in a second. So same thing, I need the physical device, the Q family count, and then Q families dot data. Alright, let me explain why I'm an idiot. That's really important to understand why I'm an idiot. The reason I say that is because here's what I thought. I thought that he is using the same variable for Q family count and Q and graphics family to indicate the index. Then realizing that completely two separate variables, but I still don't understand why he's using std optional. In a second, I'll go through his code and I'll kind of see whether it's needed or not. So I'm just gonna shut the fuck up for now. Okay, the structure contains some detail about Q families. Okay, so we have this. It's a structure. It has details. It's filled. All right. So I need the for loop here to go through the Q families and check the Q flag to see if it has a graphic bit. If it does have a graphic bit, then I return the index, which in my case I'm gonna make it a fucking integer, right? I think I'm just gonna make it an integer. So yeah, so get our lovely for loop. I don't like this auto for each thing they use in C++, so we're not using that. No, sorry, oh, what did I do? All right. Few families. That few families. Size. Not tree size. Size. I keep getting an error on the stream for an issue with the audio stream. I don't know what that is. All right, hold on. Let me listen to myself and see if there's an issue. 1 second. Un momento. All right, I sound fine. I don't know why YouTube is being YouTube. All right, cool. We got this. Next. I lost my focus. Are you happy, YouTube? Q families at I dot Q flags. Where's the Q flags? Q flag field is VK Q flags. Q graphics bit 1. KQ flag. KQ flag bit. Alright. Need an if statement. Then int Q or graphics family equal to -1. Alright, so do that as -1. There we go. Easy enough. Alright, so if graphics family index is bigger than -1, std graphics family found at, why am I doing all this? At index graphics family. First, please work with me here. All right. All right, so let's try this. Ow, sorry. Ow. I hit the thing, the table with my elbow. Don't care about you. And this crashes immediately. Null deter. Access violation. What's null? Oh, physical device null. What? Why in the fuck is physical device null? BK physical device. What? Wait, what? Why is it null? Whoa, 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 whoa. That's not good. Why is this null? Wait, what? Wait, what? How's this null? Excuse me, sir. What do I do? What do I do? What's your issue? BK result is unscoped. Prefer enum clause over enum. I don't know what that means. Okay. Huh. Okay, it doesn't seem that I assign physical device anywhere here. Wait, I didn't even do the physical device? That makes sense why I stopped then. No. Here, I get number 8 then. I do all of that. Have my loop. Is the device suitable? Okay. He's assigning the physical device here. Oh, that's when he does his whole thing. Okay. These are the feature. These are the devices. Okay. This is VK physical device. This is VK physical device. Okay, that's all correct. I just don't assign it anywhere, I don't think. Yeah, I just don't assign it ever. That's okay, that makes sense now. So I found the index here. Oh. Why would I want the index here? I already found it. Like, why do this? If I found it, I'll just do physical device equal to devices at I. And just do this. Like, why? I don't need this. Cool. He's doing it in different ways, so that's fine. Alright, so. Hell yeah, baby. Here we go. Alright, so. Geometry shader, physical device 0. Index is 0 on screen. What about the Q family? What happened to Q family? Alright. Next. Q families. Okay, there are 3 Q families. The first Q family is there's just indices. Doesn't really tell me anything about that, but okay. Q family, like with 15, this is one. I'm gonna find it. Okay, I'm doing something wrong. This is not how I'm supposed to compare this. I don't think, because he did like an AND thingy. And it's a bit operator, and I don't know bit operators in C++ or well, in C in general. He did this AND thingy. What the fuck does AND thingy mean? If I do the same thing, will it work? I don't know what this AND thing, by the way, is. Just for the record. Let's see this. It works. So this is 15, and the value of this is 1. So I don't quite get it why this is, like, I don't know what this means or what this does. The AND thingy. I have no idea what this is. I know it's a bit operator, right? I know that. But other than that, I'm clueless. BKQ family. Can I go to this enum? 0, 2, 4, 8, 10. Where are their options here? Count. I don't need the count. Okay, I want to see this. Hold on, I want to see this. Good documentation. Is that the same? Oh, no. Okay, that was extremely unhelpful. Let's just look this up. Alright, so the count, the flag. That's what I want to check out. What is this flag thing? Is a bit mask of VK indicating cumulative the queue in this queue. Okay, so I don't know how to use bit masks. Why can't you just make it a normal value? What is wrong with just making things simple enough? I need to fucking understand bit masks. I don't like writing code that I don't understand. Let's see how this fucking shit works. Briefly, bitmask has to manipulate position of the multiple values. Okay, so yeah, that's why. Okay, because okay, that makes sense. There's a good example here, bitmap storing multiple values which are not mutually exclusive and one variable. You can probably see them before. Each flag is a bit position which can be set on or off. You have a bunch of bit masks defined as 1, 2, 4. Okay, that makes a little bit sense. So if you go here, and this is saying it's the first bit, but the first bit is not 15, because this says 15 and it's not 15. It says 15. Oh. Okay. This is not 15. I don't know how this works. I don't. Bit mask. Example. So alright, so ending, here we go. In order to execute the subset of bits in the value. Means nothing to me. I don't know what that means. Here, here we only mask, no shifting necessary. Input, mask, output. That is not helpful. Maybe it's helpful. Input, mask, output. Okay, so the mask is, let's go 0. The input is that, so it masks is 0. 1 is 1. Goes 0. Goes 1. Okay, so this is like the AND operator. You know, you want to make sure. Okay. So how does this work here? Okay, so here's what I'm gonna say. I completely understand this. No fucking idea how this works. And so because I understand this, zero idea how this works. I'm gonna continue with this tutorial because I completely understand this. No fucking clue how this works. So, this is great. Yes, I agree with everything you have said. Masking is great. Yes. 100%. I finally found that index 0. Fucking yeah. Alright, we're done with this tutorial. Next. Input device and queues. After selecting a... I need a sip of coffee. Hold on. Oh yeah. I feel the anxiety rushing and the panic attack rushing through my body. Love coffee. Love panic attacks. Alright. After selecting a physical device to use, we need to set up a logical device to interface with. Hold on. What? After selecting a physical device to use, we need to set up a logical device to interface with it. Why would the fuck would you need a logical device for a physical device? Why not? Okay, I guess we'll understand that later on. Oh, he does explain it. The logical device creation process. Oh, he does not. The logical device creation process is similar to instance of creation process and describe the features we want to use. We also need to specify which queue to create. Now that we've queried which queue families are available, you can even create multiple logical devices from the same physical device if you have varying requirement. I don't explain. Okay. Start by adding a new class member called, okay, we're start a logical device. Okay, so probably gonna call this the logical device, not device, but okay. Next, create a logical device function. Okay, easy enough, understandable. Specifying the queue to be created. The creation of the logical device involves specifying a bunch of details in the structs again, of which the first one will be vk device queue create info. This struct describes the number of queues we want for a single queue family. Right now, we're only interested in a queue family graphics availability. This struct describes the number of queues we want for a single queue family. So a queue family can contain multiple queues, of which a graphic queue is one of them. And so we want to create a logical device to do something. Don't know what the fuck for. Okay, so here's your device queue creation. Oh, okay. Struct typic type device queue create info. Okay, so we've done that. And then we give it the graphics, the queue family index that we found, and the queue count that we want. Okay. The currently available driver will only allow you to create a small number of queues for each queue family, and you don't really need more than one. That's because you can create all of the command buffers on multiple threads and then submit all at once on the main thread with a single low overhead call. Whoa, wait. What? Hello? Huh? What? Huh? The current available drivers will only allow you to create a small number of queues for each queue family. Okay, so we discussed that the queue family can have multiple queues, and the driver will only allow you to create a small number of queues for each queue family. Okay, and you don't really need more than one. Then why in the flying fuck would you make, or would you have a queue family with more than one queue if you really don't need more than one? That's because you can create all of the command buffers on multiple threads and then submit all of them at once in the main thread. That's because you can create all the command buffers on multiple threads and then submit all of them at once. So is it like you have multiple multiple logical devices, they have their own queue families on multiple threads, and then they all submit into one physical device? Question mark? Don't fucking know, we'll see. Vulcan lets you assign priorities to queue to influence the scheduling and the command buffer execution. Vulcan lets you assign priorities to queues to influence the scheduling for command execution using floating point numbers between 0 and 1. This is required even if there's only a single queue. Okay, so 1, most important. Specifying and using device feature. The next information to specify is the set of device features that we'll be using. These are features that you need to query support for with get graphic device features. When the use chapter like geometry shader, right now we don't need anything special, so we can simply define it and leave it as everything to VK false. We'll come back to this structure once we start doing more interesting. Okay, sure. VK device features. Creating the logical device. With the previous two structures in place, we can start filling the create device create info. VK device create info. VK device queue create info. Okay. PK type create info. PK struct typed. Okay. First add pointer to the queue creation device. Okay. So this is the. I don't. Let's go. Okay. So this is. So I have a bunch of information. I fill it. I fill the queue with what I want, and then I assign the queue over here. I tell it, okay, so create a logical device with a single queue family, which contains. Didn't we just do a fucking queue family? BK queue family properties. Okay, so okay. Okay. In here, we are checking if the physical device supports a certain queue family. Once we found out that it supports a queue family, we create a logical device. Well, not yet. We don't create the logical device. We create a queue. We need now to create the actual queue. Before we were just checking if it supports it. Once it supports it, we actually start making the queue and tell it which index is the queue at, how many queues there are, and the priority. And then we actually make the logical device. We give it the queue families, how many queue families we have. Okay, this is starting to make a little bit of sense, but I still don't understand why do we need a logical device. I keep saying physical device. I mean a logical device. Why do we need a logical device? The remainder of the information is bare resemblance to the create. Okay, that requires you to specify extensions validation. Okay, I understand all that. An example of device specific extension is swap chain, which allows you to present rendering images from the device. From that device to the window, it's possible that there are Vulcan devices in the system that lacks this capability. For example, because they only support compute operations, will come back. Okay, it's fine. I don't care. Previous implementation of Vulcan made a distinction between instance and device specific validation layer, but this is no longer the case. That means that. Why is it no longer the case? Oh, okay. So hold on. I need to read this line again. Previous implementation of Vulcan made a distinction between instance and a device-specific validation layer, but this is not like this. It means that the enable layer count and the pp enable layer name field in the vk create device info are ignored by up-to-date implementation. However, it's still a good idea to set them anyway to be compatible with all the implementation. I don't give a fuck about older implementations, bro, but okay. We did that. We won't need any device. Okay, that's fine. Cool. Okay, so we check if it's successful. The parameters are the physical device to interface with the queue, and using info we just specifying the optional location callback pointer value logical device handler. Finally, this is creation the function. Dude, you did not explain why do we need a physical device. Can someone explain why you need a logical device? So do people actually have the command and layouts for this whole setup thing memorized? I mean, I understand it, but no way I could retype it without using references. Not sure if this is no, everyone is the same. There's nothing wrong with that as long as you can memorize the concept well enough to roughly design a good structure for your application. Yeah, everyone's the same, so shut the fuck up. Can someone explain? For anyone following the tutorial 2020, it appears that device level validation layer are deprecated, so you can enable. Thank you. For those using, I don't give a fuck. Don't care. Don't care. Can I use multiple physical devices at once, like using a dedicated GPU and running and integrated? I don't care. Someone explain logical device. I've been following the tutorial for quite some time. I've been running a bit of problem with creating a logical device. Okay. Can you make it non-graphical? Nope. Can you forget? Nope. me only requesting the queue that you need to use logical. However, if I look at the official current Vulcan example, it seems that they request every queue when creating this device. What is the downside of this? Don't care. Can someone fucking explain what a logical device is? So I'm getting segments. I don't care. Great tutorial. Fantastic tutorial. For any reason, the VK device queue function is throwing. I don't care. I want to think. It's all fucking useless. You guys are completely, utterly useless. Either I did read what a logical device is and I glossed over it, or I'm fucking stupid. Which is, both could be very true. After selecting physical device to use, we need to set up logical device to interface with it. But why? What? I don't get it. Logical device versus physical device Vulcan. Oh my god, I butchered that. Okay, here we go. O'Reilly, thank you, buddy. You got this. Vulcan divides the representation of a device into two. Shut the fuck up. I'm reading. Vulcan divides the representation of device into two forms known as logical and physical device. Physical device. A physical device represents a single workforce that may comprise of a single GPU, along with other hardware parts that work together to help system accomplish submitting jobs. On a very simple system, the physical device can be considered to represent the physical GPU unit. That's understandable. We get that. Logical device. Logical device represents the application view of the actual device. What the fuck does that mean? What? OpenGL does not expose physical devices. It connects them behind the curtains. Vulcan, on the other hand, exposes the system, real computing device, or GPU to application allows the application to know. This line does not. Can you fucking expand on that, buddy? Physical device usually represents single. Yes, I get that. A logical device represents an instance of that implementation with its own state and resource independent of the other logical devices. Why would you need multiple logic devices? I don't get that. When do you need to use more than... Thank you, smart person who's asking the right questions right here. In OpenGL, we need a device per... Oh. In OpenGL, we need a device per thread in order to do several actions in parallel. In Vulcan, we can use queue and command pool per thread in order to several... So when do you need more than one logical device if you only have one physical device? The concept of... Thank you, someone explaining shit. Okay, the concept of a logical device needs to be distinct from the physical device, because you need to be able to register extensions, feature, queue counts, and other initialization time constructs. Dude, I can't fucking read. You need to be able to ask what the physical device capability are. Then you need to be able to construct a thing that uses a specific subset of them. Okay. Okay. Given that the separation is useful, why bother adding an arbitrary restriction that says that a single application can only create a single VK device from a single physical device? After all, physical device already needs to be able to service multiple applications. That is true. Each application needs to be able to allocate GPU resource. That is true. And those resources need to be distinct from one another. They all have to be able to execute commands in parallel, which does not interface with each other. Besides taking up computational resources, so the implementation already has to be able to serve many masters, including the OS. So there's no reason why an implementation could not allow a single application to have multiple interfaces. No, okay. So it's not a question of need. Implementations already de facto have to be able to do that. So it's hardly a burden to force them to do, okay. However, if you want an example of where it might be useful, consider a program that has a DLL-SO-based plugin architecture. The program uses Vulcan for some purpose, but one of the plugins might want to use Vulcan for some purpose. They both are part of the same process, but they're not trying to render into each other's surfaces. They don't need to speak to one another or know. Okay. Okay. That is making a little bit more sense. So, you have a single GPU, right? Okay. You have a single GPU like this. All right. And then you have a logical device. I'm going to call it LD. Another logical device called LD. Another logical device called LD. This does graphics, for example. This does, so this is G for graphics. This does, I don't know, command, compute stuff. So C. This does stuff. And they all interface with the GPU and submit stuff to the GPU. I think I understand now. Oh, so this is useful for multi-threading, like the guy was talking about, right? So for example, this can be running in its own thread, doing its own thing, and then submitting commands to the GPU. Cool. I think I understand. Okay. Yep. As another example where this is definitely needed, an app in Android might do its own Vulcan rendering into surface view for 3D scenes, but also uses the UI toolkit for some other things. If the UI toolkit internally uses Vulcan implementation detail, they would need their own logical device. This happens today with OpenJS app and UI to have separate GL context, not because of different threads, but because they implement independent clients. Maybe the OP has edited some of the answers, confusing to me. English, okay. OP talks about when you need multiple logical devices. This answer starts off talking as if you can only have one logical device, then talks why this restriction does not come to need despite this restriction not existing. It does not appear to address the OP. It does address the OP. Okay. I guess the English is different. Cool. I mean, as in, yeah, he doesn't understand the language very well. He does say that. Where does it say or imply that? Yes, it starts talking about. Shut the fuck up. Why argue with the guy what it says, what he doesn't? Just answer the question to him again in a different way. Like, you don't have to be a fucking dick. Mr. Nicole Bolas, I don't fucking know. Yeah, sure. Given that the okay, so it comes off as a rhetorical question that would perhaps be explained by the rest of your post. I now suspect that you're literally asking OP why one would want an arbitrary restriction. Okay. Use of okay, this is now all shit. Okay. Yeah. Thanks for repeating the same fucking answer, you fucking dipshit. Physical class. Physical class is a data type that allows use of representation of each piece of hardware. That's not, yeah, that's physical device. Where's logical? Okay, logical device properties. PKL is data type that will use representation properties of each physical device. There's not much to say here other than we will pass a pointer to this. Okay. Getting started with the physical device properties. What is this? Another tutorial? Device queue. Okay. The next step to creating HQ, however, does best. Okay. Device creation info. Create device. That's just been fucking useful. I absolutely use this. What is this website? Harry loves code. Get. Okay, Harry. Mr. Harry. Missing book name. It seems that you love code. So let's talk about that. where software teams break knowledge silos. Okay, I was talking with Harry. We're chatting with Harry. Mr. fucking Harry. What? Okay, sure. Can I get another answer just to get this in through my head? Just want to make sure I understand this correctly. What is the difference between physical device and logical device driver? Okay. I'd like to know the difference between logical device and apart from this difference that logical device driver is written by the operating system vendor. I don't think it has had nothing to do with Vulcan because it's mainly 7 years ago. Or does it? This has nothing to do with Vulcan. Is there a tag for Vulcan or anything? It's hardware device driver. Well, driver stuff, that might be useful. Hold on. Logical device driver is a high-level abstraction of how a device behaves. A physical device driver is a driver for a specific piece of hardware. The logical device driver talks to a physical device driver for keeping abstraction, okay? For example, there are many different types of printers, and they typically come with their own driver. However, you could want to have to code your application to deal with all these different drivers. Instead, you talk to the logical driver using a standard print API, and the logical driver. Okay, so sure, has nothing to do with what we're doing, but okay. I mean, it's kind of really similar, if you really think about it. I'm writing a C++ wrapper for the Vulcan API, so I want to make sure my documentation doesn't contradict. I read that correctly. Cool. So you can't create an infinite VK object from the same VK device. If the implementation doesn't want to support more than one, it does not have to. Cool. How will you be preparing with Vulcan? Is this useful at all? I don't know, let's see. In Vulcan, there's something called a Vulcan Instance. This represents the base Vulcan system itself. Understood. Individual devices register themselves to the instance. The Vulcan Instance system is essentially implemented by the Vulcan SDK. Makes sense. Physical devices represent a specific piece of hardware that implements the interface to the GPU. Each piece of hardware that exposes a Vulcan implementation does so by registering its physical device with the instance system. You can query which physical devices are available, as well as basic properties. Okay. You can then create a logical device for the physical device you use. Logical devices are how you actually do stuff in Vulcan. They have queues, command buffers, and each logical device is separately mostly. Now you can bypass the whole instance thing and load devices manually, but you really shouldn't. At least not unless you're at the end of development. Vulcan layers are far too critical for day-to-day debugging to just opt out of that. I don't know what that the fuck means. There are mechanisms in core Vulcan won't allow individual devices to be able to communicate some information to the devices. In 1.1, only certain kind of information can be shared across physical devices, namely fences, semaphores, and even then only Linux through syncs file. While the API could provide mechanism for sharing data between two physical devices, at present, restrictions we have matching UIDs and therefore are the same device. Don't care. Dealing with SLIs covered extension, Vulcan, and device group creations from a device group. Okay. The idea with this is that the SLI aggregation is exposed as a single VK device, which is created from a number of VK physical devices. Each internal physical device is sub-device. You can create sub-devices for some information for some properties about them. Memory allocation are specific to particular sub-device restricting. Okay, that's all useless to me, buddy. Yeah, don't fucking care. Because Vulcan has the maximum number of limited logical devices creation. I don't know. Vulcan specs says multiple logical devices can be created from the same physical device. Logical devices creation may fail due to lack of device-specific resources in addition to other. So number of devices you can create is limited, obviously, since each one must use some resource and resource finite, but the number is implemented. Okay, cool. The Vulcan. It's possible that some of the resources are being reused as per process rather than subsystem wide. Have you tried spawning? Okay. Useless. I'm sleepy. Get coffee. Hold on. Oh yeah. Hit me with that anxiety. Okay, let's see. The next step is to create the VK logical device object, which correspond to one of the physical devices on the system. The logical device is a key object used later to direct commands to the hardware. So far, our sample have determined how many physical devices you have. The sample utility function for inverting devices, picking device. To make things simple, just take the first device. Okay. You can see this device. Okay, a more complex program may need extra effort to decide which device to use if there are more than one. Here's, okay, I don't care, devices and queues and families. Now that you picked a physical device, you can create a VK device or logical device object. But to do that, you need to supply information about the queues, device queues, and queue families. Unlike other graphics API, Vulcan exposes device queues to the programmer, so that the programmer can decide how many queues to use and what types of queues to use. A queue is the abstraction mechanism used to submit commands to the hardware. A queue is the abstraction mechanism to use to submit commands to the hardware. A queue is the abstracted mechanism used to submit. Okay. You will see later how a Vulkan application builds up a command buffer. You'll see later how a Vulkan application builds up a command buffer full of commands and then submitted them into a queue for asynchronous processing by the GPU hardware. Vulkan aggregates queues accordingly to their types, into queue families. In order to find the type of characteristics of a queue you are interested in, you can query for queue families. So queue families only hold the same type of queue. All right. So VK instance. Okay. The program the sample program processed by making the following call obtain the queue information. Info is a vector of queue families. You can inspect the sample code to see that sample follows the pattern described in section. Blah blah blah. The queue families property struct is called family because there may be many queue count queues available with a specific set of queue flags. For example, there may be 8 queues in a family that has VKQ graphics bit set. For example, there may be 8 queues in a family that has a queue family. What? For example, there may be 8 queues in a family that has the queue graphic. Why would there be 8 queues in the queue family? The queues are queue families on each device might look like. Okay, VK instance, the physical device. This VK transfer queue. Queue family, property 0, queue family, property 1, VKQ. The queue family is index 0, queue family index 1. Why is there 8 over here? The VKQ flag bit indicate what sort of workload each hardware queue can handle. For example, a device may define a queue family that sets VK for normal 3D graphics. For example, a device may define a queue family that sets, okay. But if the same device has specialized hardware for doing pixel block copies, it may define another queue family with just the VK transfer set. This makes it possible for the hardware to process graphics workload in parallel with blit workload. Note that there's also a queue type for compute operation which does not cover in this tutorial. Some simple GPU hardware may advertise only a single queue family with multiple queue types in each one. So queue family properties, VKQ graphics transfer. That's queue family. For now, assume that the sample program really only interested in drawing simple graphics, so they just need to graphic bit. It is important to note that queue families is not represented with a handle, but in an index instead. Once a queue family index has been filled out, structure, More complex program may wish to submit graphics command on more than one queue. More complex programs may wish to submit graphic commands on more than one queue. If more than one is available, but since the sample are simple, only need to take one here because it's only queue value. Creating a logical device. With the questions queue settled, creating a logical device is straightforward. At this point in the tutorial, you did not need to worry about about extensions. Okay. That confused me even more. So hold on. He's saying here that a single queue family can have multiple jugus. Okay, so this is 0. Okay, so I only have 3 queue families, and only the first one does graphics, according to my one. Okay. And then I specify the index number, which is this, right? Mother of fucking tits. Okay. So that's in my case. But I still don't understand. I understand the physical device. He's saying that taking device a queue is the abstracted mechanism used to submit a command to the hardware. So we use a queue to submit a command to the hardware. Okay, that's simple enough. You will see later a Vulcan application builds up a command buffer and command. Okay. Into a queue for asynchronous processing with GPU hardware. Vulcan arranges queues according to their types into queue families. In order to find the type characteristics of the queue you are interested in, you may query for queue family properties in a physical device. You can inspect the sample code that the queue family is called family because there may be queue count queues available with specific queue flag. For example, there may be 8 queues in a family that has... Okay, so hold on. So if I go to my code, put a breakpoint here, go to my queue families, and index 0, they're 1. There's 2. And there's 2. So there's 2 queue families that do this. So there's 2 queues in this queue family. There are 2 queues in here that they do something. There's 2 queues in here. There's only 1 graphic queue. Okay. So, hold on. So in my GPU, what about compute bits? Can I see how many compute bits do I have? Compute queues. Oh, the first one also does queue compute. And the second one. Okay, so the first and the second, they can do queue compute. They can... The first, index 0, can do both graphics and command queues. What about this transfer thing? Okay. Okay, the first one can also do transfer. The second one can also do transfer. And the third one can also do transfer. So all 3 can do transfer a bit. Okay. What is this? I've never seen this. Sparse binding bit. This can do sparse. First and second. All 3 can do sparse. Or 3 families can do sparse. The first family can't do queue protected bit. Or the second, or the third. Okay. Okay, so to understand this a little bit better, the first one can do graphics. The first queue can do graphics. The first queue family can do graphics. And it can do compute. The second one, the second queue family, can do compute and transfer only. And sparse binding, I think. Yes. And all three can do sparse binding. Okay, so first queue family can only do graphics and compute. Only graphics and compute. Only graphics and compute. The first family can only do graphics and compute. So here, what he's saying is that structure, which is family properties that I'm doing. Is it family properties? Yes. VK family is family because there may be queue count available with a specific set of queue flags. For example, there may be 8 queues in a family that has the queues and queue families on such device might look like. The queue flag indicates whether sort of workload. Okay. Okay. Note that there are also queue tabs compute operations. Okay. For now, let's assume program only interested in queue family. More complex experiment would submit graphics. Okay. More complex programs may wish to submit graphics command on more than one queue. If more than one is available, but since the sample are simple, you can only submit. Okay, that's fine. We only have one queue that supports graphics anyways, so we can't do that. So that's fine. Okay. 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 Okay, buddy, are you gonna help here?
Hello, everyone. Welcome to another episode of CUDA Education.
Hi.
Today, we're going to talk about physical devices and logical devices.
Okay.
Devices which helps us to actually request and implement what we want on that specific physical device.
Okay.
So my plan is just basically to draw out a bunch of stuff and
Draw, buddy,
API
draw.
core, individual studio, and to a physical. This is GPU 0. Okay.
Okay, makes sense. Easy to understand.
So
Next.
we have our API, Vulcan API core over here, and we have our physical device over here. And we need the two to work together so that, for example, we can render a triangle on a screen, right?
Okay.
With color, all that good stuff. Okay. So we have our Vulcan API on this side, physical device on that side. All right. So this is sort of the purpose of what they call a physical device. It's basically getting Vulcan to basically acknowledge a specific GPU and basically trying to figure out what are the capabilities of this GPU.
I get that.
It might not just be one GPU. There's going to be several GPUs. So maybe you have 3 different GPUs in your system that you have access to, and those 3 GPUs are very different. They have very different capabilities. They have very different things.
Makes sense.
So what your application has to do now is to find a GPU that can do what your application is trying to achieve. So in our case, we are trying to do some kind of graphics, which is presenting a triangle with color to a screen. Okay. So what are the things that we would sort of query the physical device for? You know, when we're creating our physical device, what are some of the things that we can do? So one of the first questions that you would ask is, do you support Vulcan?
Okay, makes sense, man. Move on.
Important question. Vulcan and they're not. Do you have? So there's texture capabilities for your route questions that we have. This relationship between the Vulcan API core instance and the physical device is almost like dating. So Vulcan is dating GPU.
Nice. Love dating. Next.
Okay. So what queue questions? So we're going to continue with the question dating GPU 0. And in any dating situation, there are a lot of questions. So we're going to continue with the questions. Some more questions that we have is queue families.
Okay, here we go.
Supported. Okay. So what queue families do you support? What are the things that you can do with the GPU, right? In terms of a Vulcan conversation. So some of the queue families you have are graphics related queue families. So this is about putting pixels on a screen. Okay. There's compute related queue families. This is more focused on straight computational power. You're not trying to you're not trying to present anything to a screen. The GPU might not even be connected to a monitor where you can see something. It's straight computational parallel processing that you're trying to do, and you're using Vulcan as your means of doing the parallel processing and all that stuff and communicating with the GPU. And then there's other things like transfer and like sparse memory or what have you. But I'm not too familiar with sparse memory. So Q families that are supported. So again, the Vulcan API core is sort of querying the physical device to find out what are the capabilities of the hardware and what are the sort of capabilities in terms of Vulcan Q families does it support.
Got it.
Again,
Next.
it might be related to the version of Vulcan that you support.
I hate you. Next.
So this now is all talking about the physical device side of things. So let's say this GPU it's only a compute GPU, and we're trying to present a triangle to the screen. So we're not going to use this GPU because it's not it doesn't have graphics capabilities. It's purely a computational GPU. Has no ability to present graphics or anything like that. So
I'm gonna murder you.
A triangle to the screen,
Next.
so we're not going to use this. We're not going to use this physical device. Okay. So what we're going to do is we are going to use a different GPU. So let's say we do.
I actually hate you.
So now we know that it is a graphics GPU. How do we go about requesting the features that we are? How do we go about requesting the features that we want from the hardware? Well, we do that via logical device.
Okay.
And the thing about logical devices is that you could have many logical devices.
Okay. No, that's so far.
It doesn't have to be just one logical device. But here's the thing now. Since we know that GPU 1 can do graphics and stuff, we're also, through the logical device, we're also going to ask, is the swap chain extension available on physical device? So through this, we're going to ask, swap chain extension available on physical device. So first of all, it might surprise you guys that actually the swap chain is a function of the GPU. The swap chain is not inherently a part of the Vulcan API core. It is part of the physical device or the GPU, and it's an extension of the physical device and GPU and all that stuff. So all this conversation about swap chain and stuff is really part and parcel of the GPU itself and not necessarily Vulcan, right? So that might surprise you. I know, we've discussed swap chains in other discussions and what have you, but it's very important to understand that it's an extension off of the physical device, and we manage that through the logical device. So the logical device says, okay, is the swap chain available? We're going to use the swap chain, and then also what Q families. So we want graphics Q family. Okay? So notice, guys, here we're through the physical device conversation, we're simply querying to find out the capabilities of the hardware. But through the logical device, we are requesting, like, we want to use a swap chain extension and we want to use a graphics Q family. So now we're requesting things that's going to be our relationship with the physical device. Okay, so the physical device is kind of going to be an interface between the application and the logical device is going to be an interface between the application and the physical device. All right. Just a couple things. The logical device doesn't interact directly with the instance. So remember we said this is at the Vulcan API core, and then the Vulcan API core works with the physical device, and then but by way of the logical device. But just understand that the logical device and the instance are separate and apart. Sort of the physical device is in the middle, but at the same time, if you want to interact with the physical device, you do it through the logical device. Don't ask me to necessarily get into detail about why this is the way it is, but basically, like when you're creating the logical device and specifying what you need out of the logical device, at no point do you mention the instance. All right. Another thing to note is that the instance itself also has extensions, or it also manages certain extensions. So one of the big extensions that is necessary for the instance to manage is the windowing system. So in other tutorials and to the screen, so there's a process where be able to present can be instant. We could have other physical devices, right? This is another that talks about and in code, and we
fucking hate you. You still didn't fucking explain what a logical device is. Okay, I get that you can have multiple logic devices. That's understandable. It's great. Learn capable of the physical device. We want to control physical device here. Vulcan currently does not support multi. Okay. Alright. Okay. Please tell me you're explaining this. Please tell me you can.
Hey guys, just wanted to let you know there's a brand new installment in the Vulcan API tutorial series from CUDA Education. This one deals with physical device, Q family, and logical device. It's a video tutorial.
You're useless, my friend. You're actually 100% useless. Vulcan. Use a Q, we could use object extension. There are two kind of devices, physical and logical. Okay. Well, a logical device represents an instance of the implementation with its own state resources embedded in the logical device. Let's see the number of devices. Let's see what members are there. The device visually you can select the physical device, create space for hand. Man, no one is like everyone. Everyone's saying is that you need a logical device to use Vulcan, and that you can have multiple logical devices if the physical device supports it. And you can have queues in the logical device. I get all of that. The question is, why would you want to have multiple logical devices? And one of these guys answered it already here, kind of. It's like, what if you have a DLL type of plugin architecture? The program uses Vulcan for some purpose, but one of the plugins might also want Vulcan for some purpose. They want same process, but they're not trying to render its surfaces. So you can have one logical device that does one thing with the GPU, another logical device that does another thing with the GPU. And so he was gonna. So from what I understand is, this is the GPU. You can have multiple logic devices. This is submitting some resource stuff to the GPU. This is submitting some stuff to the GPU. This is submitting some stuff to the GPU. This is my understanding of it so far from what I'm reading from everyone. Well, everyone's fucking useless. This was really the post that kind of explained it the most. Everyone is just... No one is going to detail. I hate when people don't fucking go into detail about shit. I would like to understand, why is there physical logical device? Why? Can you like fucking explain that please to me? I am too stupid to understand it myself. Spill it out like I am a 5-year-old kid. Okay. Fine. Fine. You're all assholes. That's what you all are. Okay? Just want to clear that up. It's really important you all know. Not talking about the stream, talking about the... You know what? The stream too. Fuck you guys. Alright, so we have multiple logic devices. We can have multiple, but we're just gonna make one. Okay, so physical device at next 0. Alright, let's do the fucking queues now. That's okay. So we selected our physical device here. We're queuing for family. We found our family. We found the index number. And so now we need to create our logic device. Queue family indices. Or wait, that was last tutorial, yeah? Oh, fucking no. We finished this, yeah? Yeah, we're done. Now we need to create logical device and queue. Alright. Let's add another section here. What do we call this? Search for graphics queue family and get its index number. All right. All right. Now that we got the index, we need to create our logical device. Okay, so VK device logical device. Alright. Next, create logical device function is called from VKinit. Alright, VKinit. Which is we are in VKinit. Okay. So specifying the queue to be created. The creation of logical device involves specifying a bunch of details in the structure again, of which the first one would be VK device queue create info. This structure describes the number of queues we want for single queue families. From now, we're only interested in a queue of graphic capabilities. Okay. The structure describes the number of queues we want for a single queue family. Okay. So we want to index find queue. Okay, we got that. Okay, so VK device queue create info. Alright, queue create info. Want to be consistent here. It seems that I don't put space. Okay, I think no space is nice. I guess. Okay. And then queue create info dot s type. No. S type equal to VK structure type. No device queue create as a handful. Okay. Queue create info dot queue family index. That's the index number we just found, which is this, right? Queue create info dot queue count is 1. The current available driver will only allow it to create small number of each families. They only create small number of queues for each queue family and don't really need more than one. That's because you can create all of the command buffers on multiple threads and then submit them all at once on the main thread. The current available drivers will only allow you to create a small number of queues for each queue family. And you don't really need more than one. That's because you can create all the command buffers on multiple threads. Okay, so he's explaining why you don't need more than one queue family for each queue family. Why you only need a small number family, and you don't really need more than one. To create a small number of queues. So these are queues. So you have a queue family, you have multiple queues. You can only have, he said you only need one queue in a queue family. You only need one queue in a queue family, and that would be the graphics queue in that family. Okay, that's fine. Vulcan let's say send priority flag per influencer executing flag point. Where is it? Okay, so you create info dot pq priority equal 1.0. Makes sense. What are you complaining about? Oh, we'll have to make a variable for that? Alright. That's queue priority equal 1.0. Specify use device features. Okay. The next information specifies the set of device features that we'll be using. The features that we created support with get physical device features in the previous chapter, like geometry. Right now, we don't need any special. We can simply define, leave it as VK. We can make the structure. Okay. Alright, so let's do that. BK physical device features. Device features. Device. The okay. And then I guess we're keeping that empty. Then VK device. This is where we actually create the device. Create info. I don't like create info. Device create info. Logical device create info. Do the same stupid thing over and over, please. Thank you. Okay. Logical device create info dot s type would be equal to vk structure type device create. Okay, first add a pointer to the queue creation into the device feature structs. Okay. Logical dot vq create info equal to queue create info. Queue create info. Done. And then dot queue create info count equal to 1. Dot p enable features equal device features. Create reminder from resembles of VK selectors. Okay. So this is the device features for physical device, right? Physical device features. I like to distinguish the difference between physical and logical. So, Alright, an example of device-specific extension is VK swaption, which allows you to present rendering images SCA that. It's possible that there are Vulcan devices in the system that lacks this ability. For example, because the only support compute operation, we'll come back to this extension. Okay. Previous implementation Vulcan made distinction between instance and device-specific validation layer. I don't care. Okay, create info enable. Okay. So that enable. Enable extension count equals 0. A validation layer dot create info enable static. This is for the validation layer, yeah. Okay, so we don't have validation layer, so or we don't have it yet. We're just gonna do enable layer count 0. For now, we need to add validation errors here. Paste the link. Alright, we won't need the device specific extension for now. This is device specific extension. This is okay. Device. Okay, so we're just gonna call it create device. If it did, how did I do it before? Did I make a result thing, or did I just do the if thing? I did result. Why are you mad? The enum VK results on scope prefer enum class over enum. I don't know what that means, but we're gonna use the same thing. So, oh, my keyboard died. I ran out of battery on my keyboard. Hold on, let me plug in there. Here. So, we're doing this up here. We already defined this. So I don't want to redefine it again, right? So here's what I want to do. I'd like to set this over here, and the result used like that. You know, it's about it. Yeah, I suppose let's put it here. Fine. Okay, so I don't want to recreate it, obviously. So this will be vk create device, right? Which we need the physical device. We'd need the logical device create info. We'd need a outputter, and finally the physical device. All right, makes sense. Is incompatible PK the physical device and device. Logical device. All right, so if result equal to, oh, is it success or some bullshit? Vulcan instance, Vulcan logical device initialized successfully, failed to initialize a Vulcan, failed to initialize a logical device. Logical device initialized successfully. Make sure I spelled initialize correct. I did, because I'm a champion. Alright, and that's right, yeah. VK destroy device at the cleanup. That would be whole device. Destroy logical device, then the instance. Alright, let's test this out. See if this works. And it crashes. No wonder. Alright, so what's null? Physical device is there. Create info is there. Logical device is null. I mean, shouldn't like, okay. Because isn't this where it's supposed to store the logical device? What am I doing wrong here? What am I? This is the logical device. Doing something wrong. This is the enable features. Enable features, device features. Device features is here. Physical device features. Physical device features, that's correct. Q1 create info, which is correct. It's over here. We did that. Queue creation. Alright, Q1. Q family index is the graphics family index 0. And this is there, I think. The fuck is wrong? What's the problem here? Very confused. Hold on, let's put a breakpoint. Oh, this is protect, but that's why it's crashing, because it can't find one that's correct. So hold on, what does it return? It should have returned then. What? Why did this not return? Hold on, there's something wrong with my code. Okay, didn't find. Okay. What's the graphics family is bigger? Else. I didn't have an else statement. Else. Failed to find graphic family. And there we go. That should work now. So it should get a fail. Yep, it said failed to find graphic family. Graphics family. In physical device Q family. Or okay, so and this would be VK. Oops. VK graphic. That should work now, and should create the logical device. Here's my breakpoint. There we go, and logic device initialized successfully. Alright, cool, we got this. That's done. That is a donezo. What else are you doing? Create the logical device, which we did. Where's the time? How long have I been streaming here? Can't tell. OBS is. I've been streaming for an hour and 53 minutes. 2 hours, really. 2 hour work session. That's cool. Alright, next. Okay, finally, the queue are automatically created along with the logical device, but we don't have a handle to interface with them yet. First, add a class member to store the handle graphics queue. I mean, the queue. Alright, got that. What's next? Device queues are implicitly cleaned up when the device is destroyed, so we don't need to. Okay, that's good. We can use VK device function to retrieve the queue handle for each queue family. The parameters are the logical device queue family index pointer. Okay, queue handle, because we're only creating a single queue from this family, we'll simply use index 0. With the logical device queue handle, we can now actually start using graphics card to do things. And next feature will start resource present. Okay, that's awesome. All right, so let's do dk get device queue. Device is the physical, so logical device. The queue index family is the graphics family index. Queue index. Hold on, the queue index and pointer to the value queue, because we queue and put stored in the queue. Because we're only creating a single queue family, this family will simply 0. Sure, 0. And the VKQ is the graphics queue. What do I do? Does this return successful result anything? No, just does nothing. This returns a VK result. This returns void. Okay. On this, make sure it runs. Fuck yeah. Alright, found index, geometry shader, all that successful. Alright, we're getting there, guys. Only 3,000 lines of code left. Alright, so, close all this bullshit. So we're done with the setup. Holy, well, we still have the validation layer. So we're not done with the setup at all. Man, fuck the validation layer, I swear to God. It's painful. Shit in the ass. How big is this tutorial? Oh God. Small break. Just to relax, you know, chill out for a second. Alright, so we have the Windows Surface thing. So after we finish that, well, I really need to implement validation layers, because if I don't do validation layers and if an error pops up, I'm not gonna understand how it works or what happened or what the error is, right? Which is a problem. Now here's the thing. I'm gonna go through this, what I did, and kind of explain it. So right, you have a physical device. Let me draw this real quick. Right, like I mentioned, you have your GPU. That's your physical device. This is Vulcan over here, VK. VK is interfacing with the GPU, and there here we have a logical device. Logical device, logical device, logical device. This logical device, we picked we create this one, and in here we have a family of queues, or a queue family, and a queue family can contain multiple queues. So for example, imagine this is a queue family, they're called QF, queue family, and there's a queue over here, another queue, another queue. Right now we only have a single queue in the queue family, which is for graphics. And that is working with the logical device, and logical device is sending stuff to the physical device, which is GPU, physical, which is called PD, and then Vulcan. So Vulcan communicating with the physical device, which is our GPU, and we interface with the GPU through a logical device, which has a queue family with multiple queues, but right now we have just a single queue, which is the graphic queue. So we send our stuff to the graphic queue, and then this will be submitted to logic device submitted to GPU, and yeah, there you go. So that's, from my understanding at least, how this works. And that's what we did today, right? We queued family, we want to make sure what kind of families we have, and we did that. Okay. So that's done. That's all done. And then we did the logical device stuff. All that's done. Okay, cool. Now the presentation, Windows Surface. We need to create a Windows Surface, right? To do stuff. I assume this Windows Surface is for the, so we can present, yeah, so we can present things on the screen. And then we have the swap chain. The swap chain basically switches the back buffer with the front buffer. You have double buffering. So we need to implement the swap chain. And then after the swap chain, we need to do image views. I don't know what the fucking image view is. Alright, and then after all that, we actually start with a pipeline. We start working with the actual pipeline. Holy shit. And then this is the introduction. This is very easy. And the same thing as OpenGL. And then we do our shader module. Oh my god, is that really it? Then we jump into shaders? Dude, that's not too much. Tell you the truth. So we do our shaders. I don't know why he's doing fixed function, but oh my god, we actually fucking configure. Oh yeah, we always configure the input assembly. What am I talking about? I'm a fucking idiot. Alright, so we configure the input assembly. We can, for whatever reason, also can configure the rasterizer. Color blending, will set up all that up. That's easy enough. And then the render passes. Attachment description. I don't know what this is. And then the conclusion. And then we have our pipeline. Once we set up our pipeline, we have to make the frame buffer. Jesus fucking shit. And then from the frame buffer, we start. This is where we start with the like how Vulcan works. We need to make our command pool, the command buffer and allocation stuff, streaming command recording stuff, start our render pass. This is where we do our draw call. And this is where we do rendering. You have to use semaphores. I need to understand what semaphores are. All I understand is they're like muttexes, but with signal or something like that. See how that works. And then we have our fucking that. Oh my god. And then we need to talk about frame and flight bullshit. Okay, so we have a way to go. We're still in we still need to do presentation, graphics pipeline, and then finally drawing. And then we need to talk about the vertex description, the staging buffer, the index buffer, uniform buffer, textures, depth. Okay. Honestly, if I do this every day, I can finish this week. If I do it every day. Am I gonna do it every day? Absolutely. I don't have the time nor the energy to do this every day. So, where would we left off? Presentation. From the surface. All right. All right. Okay. Give me a second. I'll be right back. I just need to stretch my legs. And after I come back, we'll do the window surface thing. Hello, lovely people. All right, so let's do the Windows Surface thing and then call it a day. All right, this is the last thing I'm gonna do because I'm kind of tired and I want to chill before going to bed. All right, let's do this. Since Vulcan is a platform, Vulcan is a platform agnostic API, it can not interface directly with the Windows system on its own. To establish the connection between Vulkan and Windows system to present results on the screen, we need to use the WSI Windows System Integration extension. In this chapter, we'll discuss the first one, which is VKHR Surface. It exposes the VK Surface KHR object that represents an abstract type of surface, types of surface, to present rendering images to. First, oh my god, I can't read. I'm too tired. The surface in our program will be backed by the window that we already opened with GLFW. The VK surface extension is an instant level extension, and we've actually already enabled it because it's included in the list returned by GLFW get. Okay. This also includes some other WSI extensions that we'll use in the next couple of chapters. Alright, so I assume this is not everything we need to do this for the like to present stuff on the window. I'm pretty sure there's stuff missing because they're using GLFW and they have this extension enabled. Apparently I don't, I assume. So I need to do more work on this. So I have to Google more stuff on this and see how it's done. But carry on anyways. The Windows Surface needs to be created right after the instance creation because it can actually influence the physical device selection. The reason we postpone this is because Windows Surfaces are part of the large topic of rendering targets and representing of which explanation would have cluttered the basic setup. It should also be noted that Windows Surface are an entirely optional component in Vulkan. If you need off-row rendering, Vulkan allows that without the hack, like creating an invisible window necessary for OpenGL. Windows Surface creation. Start by adding the Surface class member right below the debug callback. Alright, so VK Surface HKR. Do that. For now, I'm just gonna do everything in here. I'm gonna organize this class at some point, split it up into maybe multiple classes or whatever, see how this works. But let's do that. So VK Surface HKR, we're going to call it Surface, like he did. Next, all of the VK Surface object and its usage is platform agnostic. Its creation isn't because it depends on the Windows system detail. For example, it needs the HWND and the HH module handle on the window. Therefore, there's a specific extension by which Windows called VKH and also automatically included in this list from GLFW. Alright. I'll demonstrate how this platform-specific extension can be used to create a surface on Windows, but we won't actually use it in this tutorial. Doesn't make any sense to use library like GLFW, then proceed to use code actually has GL create surface window that handle the platform. Okay, to access native surface function, you need to update included at the top. So apparently I need to do this. Okay. VK GLFW include Vulcan. Okay, these are useless. Because Windows Surface Architecture comes with Win32 surface information, check that needs to be filled out, and there's two important parameters, HWH instance. Okay, so this is the okay. We need to make another one like for now. VK Win 32 surface create. Okay, so this function doesn't exist. I'm sure I need to import some kind of header for Windows. Hit the WSI or something. Okay. Alright, so we're going to write Windows specific code getting surface selection. Fabricate a server must specify the information ahead of time, like most Vulcan objects will be using PK32HKR. Okay. Doesn't exist though for me. Okay, he's making a window. Bring the swap chain in here. Okay, I have all that. Okay. None of this is particularly useless to me. How do I, where's this function? It must be in one of the headers that I need to include. And the lovely person doesn't tell me what header. Header. Put VK, include, alright. For Vulcan. Oh, I mean, they did say I should do that. But, seeing I'm a dumbass. Alright. I'm just an idiot. He literally put it right here. I did add it and then removed it, whatever. Okay. So this is Win32 surface create info. Alright. What do I need? I need Win32 surface create info dot s type equal to pk structure type Win32 surface create info that dot hwnd. That would be okay, we need the hwnd. How am I organizing this engine? Okay, so for now, the initialization is gonna ask for hwnd. hwnd. Oh, reference that. And what else I need? I need this module handle. Where do I save that? H instance. And I need my H instance. So I need both that. Which comes first? Is it the H instance first? Yeah. So I'm gonna do H instance. That. And then hwnd. Or because I don't expose these, right? They're private. So I'll just ask for a window. I'll just ask for the window. And so window, memory address of window. Can you not do that? Right? Like, I hate me. I like it this way. So I need to include platform is better. The specific namespace. BE Windows. BE Windows. Okay. I'll ask for the window, and then the window dot h lpnd. This require the window. This you're complaining is uninitialized. Uninitialized. All these are uninitialized. Fine, we'll initialize them later. Okay, so in here we don't have access to HLBND, right? So in here we'll keep them private, but I need to make this class a friend of friend C++. I forgot how to do friend in C++. Let's see how this works. Friend class B. Alright, so friend class Vulcan. Will this work? No. Member is inaccessible. But I just declared you as a friend. So... Oh. VE graphics API Vulcan. Now you guys should be friends. Your friends. Still says inaccessible. Build it. Failed. Still says inaccessible. Why? I just made you friends. We're in class A, class B. Since B is a friend of A, it can access. Since B this is class B. B is friend of A, it can access. X.A is private. This is what I'm gonna access. Yeah, that's what I'm doing. What am I missing here? Can you only build only? Graphics API must be a type. Graphic symbol on left must be a type. Completing. Do I have to include the header? I highly doubt it. Plus, I really can't do that, seeing that it's not gonna work. Namespace, graphic API. namespace Vulcan class Vulcan. Do I need to for declare it like that? I highly doubt it. Graphics API symbol to the left must be a type. Not happy. Not happy at all. Why are you not happy? I don't think this matters if it's like where I put it. Doesn't matter. Something very wrong. I'm doing something very, very wrong. I'm already in VE, so maybe I don't need VE here. Graphic API. Nope. What am I doing wrong here? There it says graphic API is not a class or namespace name. Not a class or I think I have to include Vulcan here. Graphics API Vulcan. Vulcan.h. I was not gonna happy because I already include Vulcan. Already include doing the thing over there. Definitely not gonna be happy here. So here I'm just gonna remove this. I'm gonna remove that. I'm gonna put it in the header for now. Okay. Move these. Go here. Remove this. Put it. So, see now it works. And now it works. So I need to do this in here. Right? Which means I have to for declare this in here. So namespace window and then us. Now that I for declared it, it should. Nope. Oh my. This should work now, hopefully. Yeah, it works. Cool. You are annoyed. What are you annoyed about? You need graphics. So what's next? Instance is there. The physical device is there. Logical device, no. On pointer. And then graphic queue is no. PR, and then what's next? Surface is no. Happy? Are you gonna go away now? Vulcan poly, are you gonna go away? Still being a little bitch. Graphic queue is uninitialized. I did initialize graphic queue. I made it null. Give you null. Graphic queue is not a pointer. Initialized. Gotta rebuild this. Fresh rebuild. Still getting complaint? Just how are you? These are still uninitialized, dude. It's right here. I remove the instance. Will you complain about the instance? I build this. No, you're not gonna. You're just behind. You're just gonna come. You're just gonna get fixed there. All right. Okay. So let me explain what I just did here. So, in my window class, I had to include the Vulcan header, and I had to say that the window class. I basically said that the Vulcan class can be a friend of the window class. The Vulcan class can be friends with the window class. And because they're friends, they can access the Vulcan class can access the window class private variables, right? But the problem is that the Vulcan class is including, well, I was including the Windows, the window header. The Vulcan class is including the window header. This is the Vulcan class. It's including this. It was including it. I was doing it in here. Because the Vulcan class is including the window header, and the window header is also including Vulcan, so they're both including each other, that's going to cause a problem. All right? Because one includes the other includes the other, the other includes the other includes the other, and they have a mess, right? So instead, what I've done is I've only made the Vulcan. I've only included the Vulcan class inside the window header. Okay, and then in here I did forward declaration. So forward declaration basically say, hey, tells the compiler, hey, trust me, this class exists. Don't worry about it. I promise you, you'll find it, right? Just so I can specify it over here. And now that I promised the compiler it'll find it, it'll actually find it when I include it in the CPP. If I include it in the CPP, it should be fine. Right? It shouldn't be an issue. But I can't include it in the header because otherwise this would include that and that would include that, and that's going to be a problem, right? We don't want the two classes. We don't want Vulcan and window header to include each other. We only want one of them to include the other, right? In this case, the window class is including Vulcan. Vulcan is not including it, but saying, hey, don't worry, I promise this class exists. The window class is the Vulcan class is telling the compiler, don't worry, I promise that the window class exists, and that I'll link it with you later on, and we do link it in the CPP, so that should be fine. And so now I can specify the HWINSD and can specify the H instance with the H instance. Right? I can specify all that, which is good. Right, so we've done all that. The EGL use function needs to get a raw HW, right? After that surface can be created with vk create. Okay, so let's do this. Vk create when 32 surface HKK KHR, which includes patch for instances for the detail custom allocator and variable surface and layer stores. Technically, it's still use extension point, but So commonly used the standard Vulcan letter. Alright, so this is gonna work the same exact way. So we're gonna do VK, do that. So I need the instance, the Vulcan instance. I should call it the Vulcan instance, but fine. I create info. Just create info. Yeah, so this would be when 32 surface create info. Memory address to that. No PTR, and then the surface, which is surface. Okay, I'll never address that. All that will be stored in results or result, and then we're gonna have the same. Okay, so when those 32 windows or Vulcan when 32 surface has been created like this way. Can't spell successfully, so we're gonna Google that. Thank you, Google. Successfully, and oh, I did spell it over there. Alright, so Vulcan 132 surface has been created successfully. Fail to create Vulcan 132 surface. Alright, and then we return. So that will be here. 132 or Vulcan 132. Bunch of these. Okay. That's there. There. What do I do here? What do I do here? Logical glass. Created or create Vulcan logical glass. And view and graphics. Bunch of these. Alright, so do that. Go. That's done. That's done. Done. Space done. Space done. 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 Save it. Rebuild this entire thing. See if the surface is created successfully. Fail to create Vulcan 132 surface. I love when it fails. That's exactly what I want. Why did it fail? Let's see. Is this not valid? Unused. Unable to read memory. H instant. Hold up, what? Let's have the same. That's unused and everything. Why do you fail, my friend? Instance, Vulcan, surface. Why does it fail? Why does it fail? Process is similar to other platform mechanics where it creates surface. Okay. Yes, secret surface. Vulcan Instance. Alright, let's destroy the surface. Let's do the cleanup. It's not working, so I'll fix that in a second. Destroy. Surface. And surface. Okay. Some other care what are happening. Alright, so we're failing here. Why are you failing? Why am I failing in this control? So we can with 32 surface creation of HR. Okay. Structure 5 create info. Okay. Okay, that's correct. We're giving the HLND, we're giving the H instance. And then it fails. Why is it? I should feel like we're supposed to. The Windows being referenced like it's supposed to. Failing. I'm trying to get together. Do you enable appropriate extension using? Okay, so we need to enable extension at the instance creation time. Also note that we don't need to manually get the function pointer. All right, so we need to enable extension somewhere here. Enable extensions. How do I do that? Alright, extensions, creating the Vulcan Instance information. Enable extension count, extension names. We didn't do anything about extensions, yeah? Alright, so here's the things, and this is failing. Alright, so Vulcan enumerate instance property. Extension count. Vector extension names, VK extensions, properties account, VK arm property count, and extension data for each extension count. Just pushing all the extensions here, then passing those extensions there. Okay, so he's enabling, yeah, so he's enabling every single section, which is not what we want. So this is the VK instance create info. Right here, we need to do some extension creation. So u int 32 underscore t extension count. Right, and then vk enumerate instance extension properties, which needs the player name. Instance, what's the player name? Oh, p layer. P layer name. He's passing no filter for that. Property count. It's passing this. We can say property. Yeah. right? And so here, Jesus Christ, please type. Can we run this, please? How many extensions do we have? I don't care. We have 11 extensions. All right, cool. So that's working. You are the result. This can fail. Copy this. Result. The result here. Delete that. Vulcan extension retrieval failed. Oh, not failed. Was successful. Retrieval is spelled wrong. Successful is not even close to the same word. Whatever. And they failed to retrieve Vulcan supported extensions. Right. I spelled that correctly. I mean, all I had to do is really add the name. Okay. That's done. Here's the extension count. Alright. So after you grabbed all the extensions, what else do you do? Where is it? What's that? What's that? That. Okay. So he grabbed the extensions and then he made these are the extension names. Okay. Whatever that is. I'm gonna do std vector of type bk extension properties of extend. Oh. Okay, extension properties of extension properties. Right, with the extension count is I found that back here. Got the extension count, and then we need to call the same function again. We can raise the extension property that with the this data, I assume. Yeah, and then I loop through extension counts. Where did okay, I just need to see the extension names here. So this can also fail. Jesus Christ. Fail to. I hate the fact I have to. Okay. And so now I can just for dot size be dot Alright, so I should get list of all of my extensions now. Alright, so I have device group, fence, memory, sum of 4 physical device, surface capabilities 2, pointer to surface, and all that. Alright. So now that I have the correct ones that I want, I would like to enable those extensions. So he's doing enable extension count, instance, enable layer count, enable, where's layer count? Layers. I don't have any layers, so whatever. Enable extension count equal to 000 for now. And then instance creation info dot enable enable extension names equal to, this is a const char const like he's doing. So I need an std. I need std. Not that std you're thinking about, you filthy. Std vector const or pointer extension names. Then we do extension names push back. Alright, so I need to enable a few extensions. Alright. One of the first is this. If extension equal to that list of extensions, hold on. So the list of all my extensions. Copy all of these. Paste them here. Right. So all I need is vk this really. If vk equal to that. Then push that I. Don't care about that. Also check surface. That. We need that and that. Oh, that's. Also. Yeah. You're doing, yeah, data count here. There you go. That should. What am I doing here? Oh, fuck, I fucked up. 0. Almost didn't notice that. What's your problem? Const char. Doing no percent. Okay. Const char const. PT. Session names. No. We're using that. Never. Const char pointer. Const char const PT extension names. Okay. Oh. What am I doing wrong? He has the extension count, he has this. This, he's not using this anywhere. Has the extension count, bills, and then he just does data. Extension names. It's I need to Google that. Can I see some sample code, please? I'm too tired to fucking think. Please, someone. Oh, just someone write the code. I'm too tired to think. Debug this. Don't care. Please, you were nice enough to tell me you were nice enough to type it. Oh. You have a paste bin and another paste bin, really? Really, buddy? Really doing that? Alright. Structural Vulcan. I don't understand this fucking pointer. It's different data type. I get that. A value of type. Actually. Fucking more. Oh, I am so goddamn fucking stupid. Also create. What? I literally just initialized them, man. Come on. I literally did the code. Extension names, there's 0. What the fuck is there 0? How could there be 0? What? Okay. Extension name. Oh. Oh. There, this is VKHR surface. Should pass through. Doesn't pass through. Why the fuck not? VK. Oh, it's the second one. It also doesn't pass through. What? VKHKR surface. How does this fail? What is this? This is a C string thing. Dot. Char 56. This is char. C str or something like that. C or I'm fucking stupid with that. Not. Hey, this is not a string. This is a char. This is a char array. Compare char array. Char copy. Char comps. Compare the constants. Right, no, no, oh, oh. Okay, it's adding every single one of them. Uh, okay, 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 okay. There we go, that worked. Extension name, that's correct extension. And that worked. Okay. How many extensions we have? We should have 2. That is correct. So now it should be successful. Surface upgrade successfully. Fuck yes. Alright, so you can't compare because this is just an array of strings of characters, and this is just it's a const char. I guess they're different, so you can't compare them. You have to use str comp. I don't know why I can't compare them straight up. C++ is fucking weird. There you go. That is done. So this is passing. Surface creation. Fuck yeah, baby. Alright, we're destroying the surface and then creating for support. Okay, we need to finish this later. I can't. I literally can't. I'm dying slowly. This part we'll do later. But we did a shit ton today. Like a lot. It's good. I need to commit my code and push it. So I'll do that. After that description, everything that I've done. Oh, I'm too tired for this. I'll do it later. I'll do it tomorrow morning or something. But yeah, that was fun. So after the surface, we'll do a swap chain and just the rest, and hopefully, I'll try to stream often. I promise, I try to stream often. I'm just really fucking tired. I'll say it all the time. Anywho, boys and girls, ladies and gentlemen, people and non-people alike. That's it for now. Have an awesome